All right, how's it going out there, folks? Today we're going to chat about the planets, right? The difference between the inner and the outer planets, the solid versus the gas giants, terrestrial versus Jovian. It's like this whole battle, I tell you. But anyways, this obviously a pretty cool picture, not drawn to distance scale, but size scale it is, right? That is about the relative difference size-wise, but certainly not distance-wise. I know many of you are probably still upset, Pluto getting kicked out of the club. We'll talk about that as well. All right, let's get cranking. Little comical skit. Check it out.
Attention! This is your cute stewardess asking you to remain singing until the video has come to a complete stop.
Now it's time to croon about the planets that make up our solar system. Come on! The closest to the sun is the planet Mercury. Next, the shrouded planet Venus is as cloudy as can be. The Earth is next, we call it home. Let's hope it stays that way. And then there's Mars, it's really red. What more can I say? The gassy planet Jupiter's as big as planets come. Then there's Saturn with its mighty rings made up of tiny crumbs. We travel on to Neptune, that's a gassy, greasy ball. And cold and tiny Pluto, it's the furthest one of all. There you go. That's our solar system.
You forgot Uranus.
Good night, everybody.
Hey, and we got it.
All right. So yeah, he left out Uranus, right? Not Uranus, Uranus. All right. And this little what do they call it, monocle there, kind of helps you remember him there. My very educated mother just served us nachos. The old one was, of course, just served us 9 pizzas, right? P for Pluto. But as you know, Pluto got kicked out. So just served us nachos. Now, Pluto got kicked out for a couple reasons. One is it doesn't fit the pattern. If you look, we have small solid planets, monster gas giants, and then back to small, right? So that's just kind of weird. The second is when you zoom in on it, it was actually 2 separate bodies orbiting around each other. A third reason, the orbits of the planets are not perfect circles. They are slightly elliptical, but Pluto, which means slightly oval-shaped, but Pluto was a lot more elliptical than the other planets. Put it all together, and they think it was more of a captured asteroid after the formation of the planet, so it kind of joined the party later on, not one of the original planetary formations. So that's why they kicked it out. They think it's more of a captured asteroid that is orbiting 2 asteroids orbiting the sun. Okay? All right, and there's your names, right? Mercury, Venus, Earth, Mars, Jupiter with that classic spot there, Saturn, Uranus, and Neptune. Okay? So to be a planet, well, bottom line is you are partly solid. So the inner planets have solid, rocky outer shells with hot, liquidy inner cores, whereas the outer planets are gas on the outside with solid inner cores. All right, so you got to be partly solid or gaseous, orbiting the sun around the sun, and seen because of a reflection of sunlight. Right, the reason we see other planets is because they're reflecting the light off the sun. All right, if it's not reflecting the light, it's just like Earth in night. Right, you're not going to see that in space. Okay. Okay. Brings you to a new word here, satellite. Everybody just thinks they're those man-made things that we put up in space, but no, there are natural satellites. In fact, the moon is the Earth's natural satellite, right? Moons orbit planets, and they are natural satellites. Read that through there. The inner planets, right? Sometimes called terrestrial, meaning Earth-like planets, in that they have solid surfaces, closer to the sun, relatively similar sizes. All right. And there it is. Small in size, rocky composition, mostly solid, of course, with the exception of their inner cores. Closer to the sun than the gas giants, right? That's who you're comparing it to here. Shorter periods of revolution compared to the gas giants. They don't all have the same tilt, as you can see in this picture. Okay. Earth and Mars have similar tilts. That's one of the reasons that the whole colonization of Mars has been talked about, right? Because they do have similar tilts, which means you would have that similar seasonal change. But there are big differences, right? Mars is smaller than Earth, so it has less gravity. Mars is farther from the sun. You wouldn't be receiving as much light. Mars has a slower revolution, so the year would be a lot longer. We'll show you on that chart in a minute. Okay. Mercury almost no tilt at all, but way too close to the sun to colonize. Same thing with Venus. Its atmosphere is toxic. We certainly couldn't survive in Venus. Okay. Their rotations are relatively slow compared to the gas giants, and you'll see that when we check the chart as well. Okay? All right. Outer planets, sometimes called Jovian, they're compared to Jupiter, the gas giant. And they are composed of gas, of course. They are less dense. In fact, the density of Saturn is less than water, so it would be able to float in the ocean. Okay? Mostly hydrogen and helium, and that should sound familiar to you, right? The sun, mostly a hydrogen and helium. In fact, if Jupiter was a bit bigger, it would have been its own star, its own sun, and we would have had 2 stars in our solar system, right? A binary system. They are, of course, enormous. They are much, 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 much farther from the sun. That gives them a much, much longer trip around the sun, right? A much longer orbit, which means a longer year. Okay, everything, of course, being compared to the Earth here. Faster rotation than the inner planets. Okay, and there's that term again, Jovian, right, compared to Jupiter there. This chart is in the back of the reference tables. Very, very informative. Check it out. You have your order of the planets, distance out from the sun. All right, there's your distances. A really neat part of this chart, please add it on yours, is the asteroid belt is in between Mars and Jupiter, and that's where a lot of space junk, if you will, gets pulled out of orbit through the gravitational pull of a planet, and it ends up colliding, right? You get those impact events, and a lot of those meteors would stem from the asteroid belt. Okay? It literally is in between Mars and Jupiter, and there is a huge amount of space in between there. It's not like it's a tight squeeze. No, it's an enormous amount of space in reality. Okay? These are your distances from the sun. This is how long it takes to get around the sun. Of course, this is its rotational period. And if you take a close look at Venus, Venus's year is shorter than its day. Very strange, right? So yeah, we certainly couldn't live on Venus for many reasons. This is one of them. It simply rotates too slow, so the one side would get way too hot, the daytime side, and the nighttime sun would just get way too cold because it's so slow that the energy from the sun isn't getting distributed very well. All right. There's your diameters. We'll talk about eccentricities later in the week. That's the shape of the orbit. Diameter. And of course, you can see how enormous the sun is compared to all of them. But of course, Jupiter, the biggest planet of them all, with the biggest diameter of the planets. The mass is compared to the Earth, right? So the Earth is a 1, and all these other ones are compared to that. Similar to the star chart, where the luminosity was compared to the sun, because we know the most about the sun, right? So the sun had a luminosity of 1, and all the other stars were compared to it. Well, here the Earth has a mass of 1, and all the other planets are compared to it. All right? And then, of course, you have your density. And like I was saying before, there's Saturn, right? Less than 1, so it would float in the ocean if you had one big enough. Okay? All right. So you guys are putting together this Venn diagram, the differences between terrestrial and the Jovians on the side, and what they share in common in the middle. And then there's a couple summary questions that follow. All right, so put some love into it. We'll go through it at the meet.